Okay, so today what we're going to talk about is we're going to talk about the interpreting the standard deviation. So basically in this whole lesson we're just going to be using the calculator to come up with the standard deviation. So they say in example 1, use a calculator to find the mean and the standard deviation. It says a set of 8 men have heights in inches as shown below. So these are all just heights in inches. 67, 70.9, 67.6, 69.8, 69.7, 70.9, 78 or 68.7, and 67.2. They want to indicate the mean and the standard deviation you obtained from your calculator to the nearest hundredth. So what I'm going to do is I'm going to turn on my calculator and go to the Stat button, which is always right below the Delete button. So I hit Stat, and then I go to Edit, so I just hit Enter. Then if I have anything in my stat plot, I want to just go up. So in my case, let's say that I had like 2. I had these numbers already in my stat plot. I would go to the top and keep pushing up until I get to the top. And then I hit the Clear button. If I hit the Clear button and then push down, it will clear out anything that's in there. So I'm going to start with a blank list. So L1 is just list 1. So I'm going to type in 67, 70.9, and hit Enter. So it would be 70.9. Then I would type in the next one, which would be 67.6. Hit Enter. Then I would do 69.8. Then I would do 69.7. Then I would do 70.9. Then I would do 68.7. And then I would do 67.2. So once I have these all in my calculator, I should first check the list to make sure that all the numbers are correct. So once I do that, so I have 67.0, 70.9, 67.6, 69.8, 69.7, 70.9, 68.7, and 67.2. So now I'm good. So now to clear out of this, I'm just going to hit second mode to quit out. So now I want to, here, I want to hit, so we want to calculate one variable statistic. So I'm going to hit Stat again, go over to Calculate. So if I start here, I just move over to Calculate, and I want to have one variable statistic, and hit Enter. And then I have to tell it what list I want. So above number 1, so if we look at above number 1 here, it says L1. So I have to hit second L1. So that tells me that I want to calculate one variable statistics for the list 1 that I came up with. So then I'm just going to hit Enter. So then it comes up with a bunch of different numbers that I have. I want to look for the mean. So the mean is this X bar. So the mean is about 68.975. So I'm just going to round to the nearest hundredth. So I know that my X bar here is going to be approximately equal to 69, or 68 rather, 0.98. So 68.98, because if I round this number to the nearest hundredth, that's what I would get. And then I want to know which one is the standard deviation. My standard deviation is this S of X. So it will be Sx equals, and then I'm going to round to the nearest hundredth here. So it will be 1.58. So then again, I'm going to just say it's approximately equal to 1.58. Okay? And then they say, so we indicated the mean and the standard deviation we obtained from our calculator. So we don't care about any of these other numbers. We just care about our mean and our standard deviation here. Because this does all of the work for you. It even tells you the number of values that it gives you. So n is equal to 8. And then if you keep going down, this will give you the other information that we don't really need right now. Okay. So now let's look at the next one. Okay, so all they wanted to do was find the mean and the standard deviation. For exercise 1, they say the height in inches of 9 women are shown below. 68.4, 70.9, 67.4, 67.7, 67.1, 69.2, 66.0, and 70.3, and 67.6. So then I again want to go and figure out what my mean is. So I'm going to go again to Stat, and then since it's on edit already, I hit enter. I want to edit this list, but I want to get rid of the list that was there before. So I'm going to go up to where it highlights L1, hit the clear button, and then push down, and it will clear out my entire list. So then what I can do is I can type in all of my list here. So I'm going to type in 68.4, hit enter, 70.9, hit enter, 67.4, hit enter, 67.7, hit enter, 67.1, hit enter, 69.2, hit enter, 66.0, hit enter, 70.3, hit enter, and then 67.6, and then hit enter. So once I have everything in my list, I would go through and check it again to make sure that my list is correct. So I start with 68.4, 70.9, 67.4, 67.7, 67.1, 69.2, 66.0, 70.3, and 67.6. So I have everything on there. Now what I want to do is I want to calculate the one variable statistic. So I go back to stat. Then I want to calculate, so I go over to calculate. I want to calculate one variable statistics, and then I have to tell it what list. So I go second, number 1, which is L1. And then what I do is I hit enter, and it gives me all the statistics that I need. But I only care about my x bar because that's my mean. So I could say that my x bar is approximately equal to, because we're going to round to the nearest hundredth. So it'll be 68.29. Our standard deviation is this SX. So it's a sample standard deviation. That's why we use the S sub x. That would be about 1.58. So if I write this down, it would be about 1.58. Okay? So that's how we find our mean and our standard deviation. So now let's go on to the next problem. Here. They might, instead of giving us a list of numbers, they might give us a dot plot. It says, a group of people attended a talk at a conference. At the end of the talk, 10 of the attendees were given a questionnaire that consisted of 4 questions. The questions were optional, so it was possible that some attendees might have none answered. It says, well, others might have 1, 2, 3, or 4 of the questions. So the possible numbers of the questions are either 0, 1, 2, 3, or 4, depending on how many they answered. It says, suppose the number of questions answered by each of the 10 people were as shown in the dot plot below. So they gave us all these dot plots. So we know we have 0, 1, 1, 2, 2, 2, 2, 3, 3, and 4. So they want us to use the statistical features of your calculator to find the mean and the standard deviation of the data set. So what I want to do is I want to go to, again, stat, edit. I want to edit this list and clear it out. So I go up to L1, hit clear, and then push down. So now what I want to do is I want to go through and put in these numbers. So I'm going to have 0. I'll have 2 1s, so I'll have 1 and 1. I have 1, 2, 3, 4, 2, so I'll have 2, 2, 2, and 2. I have 2 3s, so I'll have 1, 3, 2 3s, and I have 1 4. So now that I have my list in my calculator, I can go to Stat, over to Calculate. I want to calculate one variable statistics, and my list that I choose from was L1, so I have to do second and then push the number 1. Once I have that, I hit Enter, and it gives me my variable statistics. They want, our mean is our X bar. Our mean is going to be about 2. Our standard deviation is this SX, and that would be about 1.15 if we rounded it. So again, this would be approximately equal to, since we're rounding, we want to use the approximately equal to 1.15. Okay, so again, I'll just do it below. S of x is approximately equal to 1.15. Okay, so we know that our mean is 2, our standard deviation is 1.15. Okay, so we looked at this here. Okay, so we had, if we look at this data set, it kind of seems like it's that mound shape. Okay, So we should see, we figured out our mean and our standard deviation. But now let's try a different, it says, suppose the dot plot looked like this. So there's 0, there's 2 dots, 1, there's 2 dots, 2, there's 2 dots, 3, there's 2 dots, and 4, there's 2 dots. So if you look at this, if we drew like the line for our curve, it would just go straight across. This straight across is called a uniform deviation. So this one would be uniform deviation. And we know that this one up here, so for our last one, it would be kind of our mound shape. So now let's look at this. They want us to use your calculator to find the mean and the standard deviation of this distribution. So here, if I go through, I'm going to type in my list. So I go to Stat, Edit. I go up to L1, I hit Clear and push down. So now I know that I have 2 zeros. So I'll have 0, hit Enter. 0, hit Enter. I have 2 1s, so I'm going to hit 1, Enter. 1, Enter. For 2, there's 2 2s, so it'll be 2, Enter, 2, Enter. For 3, there's 2 3s, so it'll be 3, Enter, 3, Enter. For 4, it'll be 4, Enter, 4, Enter. So now I have my whole list in there. So if I look at this, I'm going to go to Stat, Calculate. I'm going to calculate one variable statistics of our list in L1. I hit Enter. So I know that my X bar here, so my mean, which is my X bar, is equal to, it says 2. So I know my X bar is equal to 2. My standard deviation is at S sub X. And that's equal to approximately, we'll say approximately equal to, because we're going to say it's approximately equal to. And that would be approximately equal to 1.49 if we rounded it to the nearest hundredth. Okay. And again, the units for this are going to be 1.49 questions. And it says, for part B, it says, remember that the size of the standard deviation is related to the size of the deviation from the mean. They want us to explain why the standard deviation of this distribution is greater than the standard deviation in exercise 2. Well, if we look at number 2, we found that our standard deviation was 2. But if we look at this, most of the data is pretty close to 2. We have most of our data ranging only 1 off from each other, from 2. We only have 2, we have 1 at 0 and 1 at 4. So, it's pretty, more of our data is towards 2 in this one. But if we go down to this one, 2, most of our data is kind of, it's uniform. So that means that each one of these is the same amount. So we have further deviation, a little bit further deviation from the mean. So, why is the standard deviation greater than the standard deviation in exercise 2? We could say that the standard deviation is greater than the standard deviation in exercise 2 because the values in exercise 2 are generally closer to the mean of 2 than in exercise 3. And we can see that if we look at, we know that the mean is 2. Most of our data is pretty close to 2. But in this uniform at 2, they seem to be more farther away. More of the data is farther away than it was in exercise 2. Okay, So what I want you to do is I want you to flip over to the back page. It's blank. Okay? So there's this next example, but I want to do something first on the back. So just flip it over to the back. I want to basically generalize the mound and the uniform shape. So if we were talking about mound shapes, so for the mound shape, so if I just drew a general number line, we would just have something that would look like 1, 2, 3, 4, 5. So if we could do like the mound shape, then I'm just going to do 4 on each side. 1, 2, 3, 4. Then I'm going to do 3 on both sides. Then go down to 2, and then it would go down to 1. And then on the other side, I would do the exact same thing. 1, 2, 3, 4. And then it would go down to 3, and then it would go down to 2, and then it would go down to 1. So that's basically our mound shape, that our data kind of goes in that mound shape. But then there's another one called uniform distribution. If it was a uniform distribution, we have our general number line, and then each one would have the same amount. So I'm just going to pick 3 dots for each one. So just 1, 2, 3, 1, 2, 3, 1, 2, 3. So all the way across, there's just 3 dots for each one. That's what we mean by uniform. That means that each data value has the same amount of data values per number. So it will look something like this. So our general curve would be a straight line across. Okay? And that just is kind of something that we enhanced from exercise 2 and 3. Alright, so now let's flip it over and let's go on to exercise 4. Exercise 4 says, suppose that all 10 people questioned all answered all 4 questions for the questionnaire. What would this dot plot look like? Well, if we're doing this dot plot, and we know that each one of the 10 people answered the 4 questions, well, there would be 10 dots on 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9,
The musical
10.
sweatshirts are in. If you have your money or if you have already paid, meet us in the main office and we'll take care of business. Thank you.
So they want to know, for part B, they want to know what is the mean number of questions answered. And we should be able to do this without doing any calculations because we know that the mean is the middle number, okay, or the average of the numbers. And if we add all these numbers up and divide by 7, or divide by 10, rather, because there's 10 values, we would get 4. So we know that the mean in this one is equal to 4. Okay? And how could we find the standard deviation? Well, how are each one of these values going to deviate from 4 or change from 4? They're not at all. So the standard deviation is 0 because all deviations from the mean are 0. And if you wanted to go through all of the steps, or just use your calculators to find that the standard deviation would be 0, you could go ahead and check that. So basically, if you look at this data, we could say that there's no variation in the data. Because the data doesn't vary at all. It's all 4s. So we could say that there is no variation in the data. Okay. So now let's look at it. It says, so exercise 5 kind of goes along with exercise 4. But it says, continue to think about the situation previously described where the numbers of questions answered by each of the 10 people were recorded. They want us to draw a dot plot for the distribution of possible data values that has the largest possible standard deviation. So there were 10 people at the top, so there would have to be 10 dots in your dot plot. And we want to use this scale. Well, we know that if we want the greatest deviation from the mean, so if we have a mean of 2, we want the greatest deviation. So we want some to be the farthest away. So we want some to be at 0, some to be at 5 or at 4. So if we have 10 samples or 10 questionnaires, we want 5 to be answer 0, 4 to match up with, or 5 to match up with 4 numbers of questions. So I've just put 5 at 0. 1, 2, 3, 4, 5. And I would put 5 at 4. So it would be 1, 2, 3, 4, 5. Because I know that they would have the farthest deviation because that's the farthest part that we go for our number of questions. We can't answer negative questions. We can't answer 5 questions because there's only 4 questions on this questionnaire. So they want us to explain why the distributions we have drawn have a larger standard deviation than a distribution in exercise 4. Well, we know that in exercise 4 there was no deviation from the mean. And here we have a lot of deviation from the mean. So we can say, so first off, let's find the standard deviation for this problem. We'll find the mean and the standard deviation using our calculator. So if we go into this, we're going to go to Stat, Edit, and we're going to clear this out. And we know that there's going to be 5 zeros, so I'll have 1, 2, 3, 4, 5 zeros. And then we're going to have 5 4s. So we'll have 1, 2, 3, 4, 5. So then I'm going to do the stat, calculate, one variable statistics, and do second L1. Hit enter. So we know that our x bar is going to be 2, and that our standard deviation, our sample standard deviation, is going to be about 2.11. Because if you round that to the nearest 10. Okay? So we know that up here it had a standard deviation of 0, and then this one it would be 2.11. So that means that there's a variation of about 2.11 questions. So what we could say is, why is this distribution have a standard deviation larger than the distribution in exercise 4? We could say that the standard deviation of this distribution is larger than the one in exercise 4 because the deviations from the mean here are all greater, if they're all greater than or equal to the deviation from the mean for exercise 4. Okay, so that's how our standard deviation works. So make sure that while I was doing this with you, in your calculator, you were doing it by yourself, so that you know how to do this for an upcoming quiz or a test that's going to be coming up, because they won't give you those steps to go along. So the steps that they gave you in the beginning, right here, on how to do it in your calculator, they're not going to give you that on a test or a quiz. So you're going to have to memorize exactly how to do it. Okay? And that would be the end of this lesson.